Excuse me if I may interrupt. We have to
Okay.
give the other speakers also a chance. But so if I can conclude from your remarks that this flywheel technology not only has usability in the storage of energy for households, but can also provide grid services as a whole and has many different applications.
Exactly.
Thank you very much.
Thank you.
Then I would like to move on to the interlinking of power and gas grids, again with Roger Nordman and Kiernan McNamara. Please give us a conclusion of your breakout sessions.
Thank you.
Sorry.
I give a brief
Okay.
introduction to our section where I spoke a little bit about the emergence of gas and electricity grids and how they, particularly in Europe and North America, emerged alongside each other. But then I talked a little bit about the energy transitions, where we are now, where we're going, where we'd like to go, and the likely divergence between the gas and electricity grids. So a lot of the interlinkages may break, but on the other hand, new linkages may emerge. And we talked a little bit about the shift in energy demand and supply and the reduced need for example, open cycle gas turbines in the future with the evolution of distributed renewable energy and smart grids and new ways, batteries, electric vehicles, solar panels, etc. And then we also talked a little bit about renewable gas, about biomethane and about hydrogen, which I think was covered also in another forum. So I think the view is that gas networks, electricity networks are diverging, they are changing, the technologies are changing, but that these changes have to be planned. The investments are long-term investments. These grids are going to be with us for a long, long time. And it's important we make these decisions today. That's all. Thank you.
Thank you. Roger, can you add your conclusions of your breakout room session, please?
Well, it's a little bit the same conclusion for every session. I mean, there is a lot of alternative for storage, for storage excedent of energy from flying wheel to power to gas, power to hydrogen, power to methanol, on the also local storage, heat. There is, and we should consider the perimeter of the energy, like not only the electrical network or the gas network separately, but we should consider them as one piece, and also say that if one energy is converted to the other, it doesn't have to pay the fee on the grid, because it's only energy conversion, it's not energy end use. The grid has only to be paid by the end user, like in the pump storage. This would be the idea. Maybe to show the baseline I could show you one slide to the baseline. If you agree, this would be this one. You see my screen?
Yes.
Okay.
Yes.
Okay. It's the Swiss simulation of my book. And in the first step, sorry, I lose. Voilà. In the first step, I go from 2 to 20 gigawatts. In December, it's very nice. Those are real data. It's very nice because you are under the limit of the grid at 15 gigawatts, but it's not very lot of electricity. In September, you have a huge quantity of electricity. You are quite happy with this, and it's still under the 15 grid. And in the summer too. The problem is if now you go to 50 gigawatts, that with me is because of the winter. It's very useful in winter, but we have in the middle season and in summer a huge problem because we are far above the capacity of the grid to absorb. It's the capacity of the grid to transport on the pump to absorb the overproduction after subtraction of consumption. And the key element, if you don't know how to use your electricity, you don't have any more storage capacity, the grid is full, you still can shave. And shave means you reduce the injection temporarily and you only use this part, or you only use this part. Yeah, you have less, obviously you don't use all the hut a few hours in the day, but you have a broader production and it's allow you to have much more electricity in the winter. And this is the key, because if you have more electricity in the, manage the peak, and it give you more options at the end. If you can use the peak, use it, but if you don't, if you can't yet use it, just cut it and you are quiet. So that was. And all the solutions that you discuss and produce are alternatives to peak shaving at the end.
And if I understand it correctly, then this shaved off peak could then, for example, be used to generate renewable hydrogen.
Exactly, or at your home.
Link the energy sectors of gas.
I'm sorry to interrupt you, but we'll have to get Mr. Norman to our panel session. So please, Mr. Norman, change your session. You'll be on in broadcast in about 3 minutes.
I quit the reunion.
Yes, please. I'm sorry to have interrupted you. We're live in 3 minutes, so please go on, Mr. Bastani.
Thank you. All right, so then we would move on to the next topic, which is the stabilization of smart grids. I would ask Mario Paleone and André Genesso to please give their conclusions of their sessions.
Well, who starts?
I think I have the same conclusion as for the previous session. So do you want me to
Go ahead.
say it again, or maybe you can leave you?
No, go ahead. Go ahead, and then I will attach my conclusion to yours.
Okay, so as I told it, we are developing a breakthrough solution to store energy based on concrete. It's a concrete flywheel, and we are now at the beta test phase with big companies like ENGIE, EDF, and Voltalia. The first test will be to make solar energy more friendly to the grid. So it will be not to store for 24 hours, but to filter out the rapid fluctuation, especially in small grids like, in fact, island. So with Voltalia, we will put a flywheel in French Guiana, which is a very small grid. And in this grids, when you put too much solar energy and you replace conventional generation, then you lose a lot of inertia. And the flywheel can bring back this inertia, and then you can make much more intermittent energy when you get this storage.
Can I just ask you regarding this inertia? Do you think this flywheel, the inertia that would be provided by these flywheels, is it possible to have this on a scale of the current thermal power plants that will go off the grid within the next decades? So all of these nuclear plants, all of these coal plants, they have massive amount of rotating mass. Do you think it's possible to basically replace this with these flywheels?
Well, this is our idea, but I don't want to be confusing. We will not make big flywheels like a nuclear plant.
Yeah, of course.
Million of tons. Flywheels are limited to a mass of a few tons. We will not make 100 or, well, we have designed a flywheel, a 300 tons flywheel with a big construction company, and it's feasible. Then after that, what we think is that the flywheel is very, I would say, has a very good fit with solar energy, because we can put all these flywheels below the solar panels. So it takes a lot of room. What we want to do is to make big solar plants producing, and below the solar panels make a lot of flywheels that will store the energy produced by the solar panels. And of course, we can bring much more than that. That is, we can use this inertia to help the grid to resist to anything that can happen. So basically, we want to make a lot of flywheels in order to help the grid to use much more renewable intermittent energy than now.
Thank you. Paolo, please, I don't want to speak of your words.
Yeah, well, the problem of grid stability, it's a very complex problem because it's a multi-time and space scale problem. Because when we're talking about maintaining the grid in safe operating conditions, it means producing and scheduling an amount of reserve that can be able to compensate for all the possible fluctuations in different time scales. So when we talk about inertia, this is a time scale which is typically in a sub-second scale. Okay, just to clarify it, when I'm talking about inertia response, it's a very high amount of power, but in terms of energy that you are contributing in injection into the system is very tiny. But then you have the problem of the primary frequency control into the tens of second scale or minute scale, the secondary, the tertiary control that are longer time horizons where you definitely need large amounts of energy. And this is a complex problem that involves not only the availability of the assets like energy storage systems, but also the changes of the ways the grids are operated nowadays, which means having updated tools for the integration of these services into the market, and also the possibility of deploying these services into several thousands of small devices. So the market should be able to embed operational frameworks where a given service can be dispatched all along, theoretically, thousands or tens of thousands of devices that are providing stability services to the system. We are not yet there. We are not yet there, not only in terms of a legal framework, but also in terms of technological solution, control solutions that we have to provide to the system. Don't forget that power systems are physical devices with the millions of state variables. It's way more complicated to keep stable a power grid than launching and landing a rocket like SpaceX is doing. A rocket has only 6 state variables, which are relatively easy to observe. A power grid has millions of state variables. And it's a machine which is big as a continent. So we don't have yet the right computational tools to solve problems for these large scale problems.
Thank you. So many challenges still ahead. Then I would move on to the resource efficient smart grids, again with Mario Paolone and Michael Haschke. Please, you have the floor.
Michael, I leave the floor to start first.
Mario, thank you. I'll get started. I'm going to summarize both sessions, if that's okay, because they are related to one another. The first session, we talked about a little bit about geopolitics and how this is challenging for recovery of the resources, of the raw materials that we require to make that green energy transition. I pointed out a few examples such as cobalt, and I think one of the possibilities is traceability of raw materials. We spoke about a little bit of the recent Science article that just came out, where it's being recommended to diversify mining enterprises from large mining groups into smaller scale ASM, artisanal and small scale minings. I pointed out some of the problems related to that, and then I showed you an example, an actual rock where we recovered the lithium from mineral spodumene, and then I showed some examples of the future demand up to calculated or projected up 2050. Examples on lithium and cobalt, and I showed you that there's a large increase in demand in electric vehicles, battery storage, solar voltaic. This is on a scale where we are not entirely sure whether we actually have the raw materials to make this transition. And this was really the key question. Do we have enough raw materials to accomplish what we have in mind? It's something that has not been studied, but that this article, this recent Science article, is touching on, and I think this is a really good question. The World Bank itself says the clean energy transition will be significantly mineral intensive, but nobody, literally nobody knows whether we have the raw materials to do this. There were some interesting questions. Somebody asked what the CO2 footprint of the raw materials mining is. Frankly, I'm not able to answer that in accurate numbers, but mining does have a significant footprint. But keep in mind that once you extract the raw materials, once they are extracted out of the mountain range, you can probably recycle them. I know it's true for rare earth element, it's true for lithium. So they will stay on the market for a very long time. And somebody else asked whether it's wise to follow that green energy transition. Well, this is not up to me to answer that question, but it's certainly, it's good to be critical, but this has been decided as a strategy by the European Commission. And we as a company, we fully support this strategic decision, but this also means that we will be mining for a little longer to actually try to meet these future demands. Then I pointed out some options. What are our options in terms of raw materials? Well, we can buy the raw materials from suppliers abroad, such as China, who's the main supplier of many raw materials, or we can get them from Scandinavia, Greenland, Portugal, and Spain, but there we're facing challenges such as, for instance, the Europe's largest rare earth element project is actually Chinese owned. The Chinese already own the strategically important raw material sites in Europe and across the world. Ask the Australians, they will know. So our options are really limited right now. We can start mining in Europe, but the public opinion about mining is not favorable. So large mining projects it's going to be at very large risk. So our only real options are to invest into raw materials projects outside of the EU, such as, for instance, Canada, and this is actually what is currently being considered by the European Commission. So I put the question into the open room and asked the audience to reflect a little bit on the raw materials demand and the green energy transition, and how they think how we can solve that discrepancy between the public acceptance for mining, the lack of a public acceptance for mining, and the large raw material demand that we need to meet the green energy transition. Thank you.
Definitely a very interesting point. Do you think this puts a limiting factor on the transition that is possible?
I think this is a really good comment. Yes, I think this is a very limiting factor unless we change the public acceptance for mining, and unless we start mining in Europe ourselves and accept the fact that in order to go forward to do the lithium challenge, to put the electric vehicles on the road, until we have hydrogen power, we have a transitional technology, and if we want to implement this, there will be no way around mining, one way or the other.
Thank you. Mario, do you have anything to add?
Yeah, just wanted to add a small comment on that. So when we are talking about planning challenges of power systems, in particular power distribution systems, we don't have to forget that we can leverage also on postponing grid reinforcement and asset reinforcement in general by deploying suitable control tools. I mean, control tools means creation of a controllable demand, for instance, which is equivalent to having a local battery that can enable to relax constraints on maximum currents that you have into transformers and into lines, which means postponing investment into copper or aluminum of these assets. So this is a dimension that has been around since more than a decade or more than 2 decades. But nobody has seriously used or seriously considered the adoption of ubiquitous control layers to control power grids exactly like we are controlling the internet and the information flow into the internet. I think that we need a change of mentality in power grid operators to explore this further dimension that has a lot of potential, which is not a concrete asset, but it's the most intelligent way of using the asset in the best way possible.
Thank you, Mario, for your comments. Michael already touched on the sustainable energy geopolitics. Gernon, do you have anything to add to his comments and conclusions? Gernon McNamara, can you hear me?
Jan has leave the session to join another session, I think.
Okay. All right. Yeah, we are already 15 minutes past our time window. I would like to thank everyone for your participation. That has certainly been very interesting. Yeah, I would with this conclude the session.